Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help you answer the question that I'm sure is just burning on everybody's mind, which is what is a logarithmic function? What is that all about? So first of all, let me go back and talk about an exponential function. My previous video was about exponential functions like y equals 2 to the x or y equals 1/2 to the x. And although these are really quick graphs, but remember that in general, functions like this, they have this type of behavior. They typically go through 0, 1. I said typically because, if somebody put a, times 2 here, that would change that. But, but functions of this nature, they go through 0, 1. If a is a value bigger than 1, like 2, 3, 4, they have this type of behavior. If a is a value between 0 and 1, like 1/2, 1/3, 3/4, then they have this type of behavior. Now, the thing to realize about both of these functions here is, well, one, they're both functions here. I'm going to use this for my vertical line. You will notice that they both pass the vertical line test. Sorry about this guy being in the way, but all right, now horizontal line. You will notice they both pass the horizontal line test. Now, it might look like maybe down the road it levels off and crosses a bunch. It doesn't. These things right here, the x-axis is what's called a vertical asymptote. This function never actually crosses that axis. So trust me, it may not look like it based on my graph, but these do pass the horizontal line test. So because they pass the horizontal line test, they have inverses. Right? Now, well, how do we find the inverse? Well, remember, to find the inverse, basically you switch the x and y values, get swapped out. So if I take this and I write it like this, we would have an equation that would give us the inverse. But the unknown y is up here in the power. So what a logarithmic function is it's the solution of this equation. Right? The solution of this equation is called a logarithm. It's the solution for y. It's equal to, let me just say what this reads. This reads log base a of x. Right? So a logarithmic function here, is the solution to an equation for the inverse of an exponential function. Right? There's a lot of words there, but that's what it is. This is the first example of what's called a transcendental function. This is not an algebraic type of function, and I think what I'll do is I'll make another video about what transcendental functions are. You don't need to know that in this college algebra class, but you need to know there is kind of a difference between a logarithmic function and something like y equals x squared or y equals x to the third. I'll save that for another video. The important things for this video, the real big things, are this. The logarithmic function is the solution of this equation right here. It's the solution of an exponential function, and it therefore gives the inverse here of this guy. And the other real big thing is this thing right here. What this means, logarithms have a base, right? So in this example here, I've got log a would be the base of b is equal to c, where c is some number. The really big thing you have to be able to do is go back and forth between logarithmic form and exponential form. And just remember, I call this the circle rule. I'm going to do this in green. This number to this power equals this value. So this equation, if you will, log base a of b equals c. This is equivalent to, that's one interpretation of this symbol, a to the c equals b. And you need to be able to go back and forth between logarithm and exponential form. I'll go ahead and do some examples of that here. Give me a moment. I guess I don't need to clear this out. You can wait. So let's get rid of this guy here, and we'll go through some examples. Clear. All right, so let me write this up here. So log base a of b equals c, right? And I always remember the rule. This means a to the c equals b. That's how you go back and forth between logarithmic and exponential form. So some examples. So log base 5 of 8 equals y. Right? This would be equivalent to 5 to the y equals 8. Or log base 2 of x equals 4. This would be equivalent to 2 to the 4 equals x. Or maybe maybe the x somehow, although this probably won't happen much, but maybe we have an x here, log base x of, I don't know, 3 equals 5. This will not show up a lot where you have an unknown in the base, but I'll go ahead and go through it. This would mean x to the 5th equals 3. Now, one that you'll see quite a bit is you'll see things like log and nothing of maybe x equals 4. If you see a log and there's nothing written here, it is assumed to be base 10 if you want to write it in, go ahead. So this would mean 10 to the 4th equals x. Another real common one is what's called the natural log. There's a very important number, and we'll talk about where this comes from very shortly probably, is the letters usually labeled E, which is, I think it's 2.7 something, goes on forever. And it's called the, I think, natural exponential number or something like that. We'll be talking about this very shortly. It has to do with exponential growth. And that's a very common base. Log base E, maybe of 5 equals x or something. This would read e to the x equals 5. Now, usually the natural log is not written like this. Log base e, very, very common. That will be written ln. Something like natural log of 5 equals x. When you see an ln, what it means is it means log base e. So again, it'd be e to the x equals 5. I'm not going to recopy that one. All right, so you've got to be able to go between logarithmic form and exponential form. Now, you also have to be able to go from exponential form to logarithmic form. I'm going to just use the examples that I've got sitting here. I'm going to shrink them down and move them over to the left. Yeah, good enough. All right, so again, when you're looking at something like this and you're trying to write it in logarithmic form, so what I do is I kind of look at these guys right here. It's a little harder for me to go the other way. Going from log to exponential is very easy. Going from exponential to logarithmic form, for whatever reason, I have to spend a little more time thinking about that. But when I'm looking at something of this form, a to the c equals b, I just kind of say, okay, a is 5, c is y, 8 is b. So this is equivalent to log base a, which is 5, of b, which is 8, equals c, which in this example is y, right? Which is, of course, what I had written here. And again, doing this guy right here, I identify the a, b, and the c. So here, the b is x, the a is 2, the c is 4. So this is going to be equivalent to log, right, base a, which is 2, of b, which is x, equals c, which is 4, right? And so forth. And I'll let you finish those out. So this is how you go back and forth between exponential form and logarithmic form. I would like you to try to fill out the notes on your handout before class, where it says, you know, what is a logarithm? Logs are the, you can hopefully answer that now. Y to the bx is equivalent to log base b of y equals x. I'm just reading off your handout here. So right under that it says y to the 2x, and then it's got this symbol right here, right? It means equivalent to, so the idea is try to write that out in logarithmic form. So hope that you can get that done after watching this video. Have a great day.